Assalamu alaikum. We were discussing combination of resistors in parallel. And we are starting with an example. These are the two resistors in parallel. Each one is having a 3 ohm circuit resistance, second is 6 ohm. We have a switch. We need to find current in each resistor, and we need to find the total current in the circuit. So you have to copy this screen. Now, when there are two resistors in parallel, we will first find the effective resistance. We will apply the ratio method to find the effective resistance. The ratio is 1:2. You have to apply the ratio and you will find the current. So 1 will having R is equal to V upon I. In parallel, voltage is the same. In parallel, voltage is the same. So one resistor is getting 2 ampere current. One resistor is getting 4 ampere current. The total current is 6 ampere. Solve it. So the total current is added. Now, what is the theme of this question? In parallel, voltage is the same. So they both are receiving 12 volt. I is equal to V upon R.
Sometimes, in order to supply current to two bulbs, it is more economical to use one battery instead of two. In order to achieve this, the wires to the bulbs need to be connected across the ends of the same battery. When the wires are long, we can make some savings by using just one of the wires as a common conductor along part of the length. At the place where the conductors separate, a junction will be formed. If we provide each of the two bulbs with a switch, we can see that when the bulbs are connected in this way, they can be switched on and off separately. Both bulbs operate independently of each other. This method of connecting electrical devices is called a parallel circuit. The parts of the circuit which are connected parallel to one another are called circuit branches. When electrical devices are connected in parallel, the voltage across them is identical. The voltage across a bulb can be measured directly at the ends where the bulb is connected and, as we can see here, also across the ends of the circuit branch which contains the bulb. In both cases, it is the voltage between the junctions in the circuit which is being measured. So it is not surprising that the measurement of the voltage across the two bulbs provides the same reading.
The main idea is here that voltage in parallel is the same. The main objective of any combination of resistor is to provide the required resistance in a circuit. So whenever in physics you are selecting a series circuit or you are willing to take a parallel circuit, this all actually depends upon the combination choice. Now look at this screen. I have some circuit components and I connect them in a battery circuit. Or look at here. This is a circuit and I select one bulb. I take another under it. This is my second bulb. And look at the circuit combination carefully. Look at this. Carefully see, the circuit is not operating because the circuit is not complete. In that sense, we need to complete the circuit. Look at this. Now the lamps are on. Circuit combination is common in our normal life. Now I want to remove one bulb. Look, when I remove one lamp, look at this. When I remove one lamp, both the lamps are gone. When I remove one lamp, both the lamps are gone. It means it is a parallel combination. Oh, sorry, it is a series combination. If I remove one lamp, both the lamps are gone. It means it is a series combination. Look at this circuit. You must have noticed that the circuit is bright. The circuit is bright. It is called a parallel circuit. Let me remove one lamp. Look at that. When you remove one lamp, the other lamp does not goes off. This is called a parallel combination. This is a parallel combination. Now, series versus parallel. Look at this screen. The left side circuit is series. Now, series versus parallel. And if you look at this circuit is series. And this circuit is parallel. So in series, current is constant, voltage is directly proportional to resistance. In parallel, voltage is constant and current and resistance are inversely proportional. So give a heading, series versus parallel. you have to copy this screen. You have to copy this screen. Let me know once you have copied it. Let me know once you have copied it. Now it depends upon the power source available. That should you select a series circuit or you should select a parallel circuit. Look at this circuit. This is series, and look at this circuit. It is parallel. Examiners have a very strong demand to draw these circuits. Circuits are commonly available. Circuits are commonly available to draw these. Circuits are commonly coming in the paper. Now, suppose you have a power source. Suppose you have a power source of 6 volt and 2 lamps each of 3 volt. Now, the power source is 6, but the lamps are of 3 volt. If you connect them in parallel, they will be in a problem because they both contain 6 volt. They will be blown up or over bright. If you connect them in series, they will get 3 volt, which is according to their demand. If you have a source of 6 volt, battery of 6 volt, and lamp of 6 volt, now situation would be better, and they both will get the same voltage what is needed. So if you have a bigger source and little devices, series is better. If you have the devices and the power source the same, you have a 6-volt battery and you have a 6-volt lamp, then parallel is better, because in parallel voltage is the same. In parallel, voltage is the same. In parallel, voltage is the same. So 6-volt power source and 6-volt is the device, then parallel system is better. Now, this is the idea. This is the idea of our circuit selection. Now, let's talk about number 3, combined circuits. Now, you have to copy this screen, combined circuit. In combined, what is a combined circuit? It is partially series, it is partially parallel. In some cases, neither the series nor the parallel combination is able to provide the required resistance. So look at this circuit. Look at this circuit. This is a combination. This is a combination. These two are in series. These two are in series. And this is a single. So they together are in parallel. So this is called a mixed combination, series and parallel both. Remember, resistance increases in series, resistance decreases in parallel. So maximum resistance comes in series, minimum resistance comes in parallel. You have to copy this screen. I'm putting the first example. You have to copy this circuit. This is called combined circuit, partially series, partially parallel. You have to copy this circuit. Now, let's start this working. Look at these two resistors. They are in parallel. The formula of the parallel is what? Parallel has a formula R1 into R2 upon R1 into R2. This is the formula for parallel. So start working and first calculate the parallel resistance. Let me know what you get. Answer is 1. Okay. Well, first see what we are getting for this. We will get 1 for this combination. There is a 2. There is a 2 ohm resistor also there. If we combine, they are in series. The final answer is 3. Complete this working. 1 was the right answer. Now, I'm putting the second example. There are 3 resistors in parallel, although 3 resistors are less important now in parallel. And there is 1 resistor in series. We need to find the effective resistance. Now copy this screen and solve it. Solve it. I'm just coming. These are three resistors. I'm showing the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. 2.67. Okay, what is the answer for parallel combination? First, share the answer for parallel combination. The answer for parallel combination is 2 upon 3 ohm. And if I take it in series with the 2 ohm, I'm getting 2 upon 3 plus 2, 8 upon 3 ohm in a fraction way. Yes. So look at this working. Now let's do example number 3. Copy this screen. The above 3 resistors are in series. The lower 3 resistors are also in series. Now the above line will be 6. The lower line will be 4. Above line will be 6. Lower line will be 4. And once you get them in parallel combination, the formula will be R1 R2 upon R1 plus R2. The final answer you are getting is 2.4. Now copy this screen and compare the answer. If you have solved it yourself, compare the answer and give me the feedback on the chat. If you are getting the same answer, let me know. Good. Now, when three identical resistors are connected in series, their combined resistance is 6 ohm. What is their combined resistance when they are connected in parallel? Now, this question needs attention. The combined resistance is coming to be, the combined resistance is 6. And there are 3 resistors. So it means 6 upon 3, each one will be 2. So it will be 2, 2, and 2. Similarly, 2 is here. So when they are connected in parallel, so work out here for parallel combination and let me know the answer. One answer is 2 upon 3. One answer suggested is 2 upon 3. Answer is B. Now look at this question. Look at this question. Which combination of identical resistors gives the lowest total resistance? The concept is there. Lowest total resistance is maximum in series and minimum in parallel. Resistance is maximum in series. Resistance is maximum in series and minimum in parallel. Now, look at this question. Three identical heating elements are wired up to the main supply in three arrangements. In which arrangement is the current from the supply lowest? Current is lowest. Resistance and current are inversely proportional. If you want minimum current, you have to get maximum. When you want to have minimum current, you will have to get maximum resistance. So it's always opposite. And remember, resistance is maximum in series, minimum in parallel. Answer is B. In series, resistance is maximum and current is minimum. Now this is parallel. Now give a new heading, short circuit. what happens in a short circuit? A very large current tends to flow through the wire, causing severe overheating. For example, a serious electrical hazard, for example, when the live wire comes in contact with the neutral wire. So what happened actually, current has a tendency to take the least resistance path. So suppose you connect two resistors and there is a thick wire in parallel. So current will not go through the resistor. Current will go through the thick wire. This is a thick wire example and a fuse is there. And the concept is there. What is the concept? That current always takes the least resistance path. This can cause a short circuit. So you have to copy this screen now. Give a heading short circuit and copy this. Now, this is our next concept. Current always takes the least resistance path. This is a very important concept in physics, and it is the source of many problems also. Current always takes the least resistance path. So just like when we are going on road, we always prefer to take the less traffic road, and Google always helping us. So this is the same thing. Current always takes the least resistance path. We have to copy this. Now, give a new heading, EMF, electromotive force. Give a new heading. Now, what is the concept of EMF? When you buy a new battery, suppose you buy a new battery and it is written on it 9 volt. It means the battery can produce at maximum amount of voltage of 9 volt. This is called EMF. EMF is the maximum voltage a battery can produce. EMF is the maximum voltage which a battery can produce. Actually, what happens that whenever you buy a cell or a battery, it is written on it. It is written on it that how much voltage it can produce. This is called EMF. Let's put the definition. The energy dissipated in driving a unit positive charge round a complete circuit. The symbol is E. It's a unit is volt. And EMF is a scalar. You have to copy this screen now. Copy this. I'm just coming. Once you have copied it, please update me. I'm just coming. EMF is equal to work done by a source upon charge. E is equal to W upon Q. The concept is there. That actually EMF is the total output voltage of a cell. Now copy this formula. EMF and PD are dimensionally consistent. They both have the same unit. EMF and PD are dimensionally consistent. They have the same unit volt, but theoretically they are not same. They are different. Theoretically they are different. So after copying the formula, you have to copy down this screen. Our concept is there that the unit of PD and the unit of EMF are the same. You are supposed to arrange topical past paper, paper 1, paper 2. And if any of you have bought the books, you please let me know. Okay, people can update me. Could try to buy the books as soon as possible. So we are stopping here and we will inshallah continue it. Okay, very good. We will continue this in our next class.